Hello, this is the Applied Mathematics BRG. I am Zach Porter.
I'm Alex McDonald.
I'm Januli.
So in this presentation we will be discussing the project management phase, the concept generation phase, the intellectual properties identification, the failure modes and effect analysis, and the economic analysis, as well as us going forward in the project.
This is our project management Gantt chart, which has been updated since our last report. As you can see, one of the tasks has been changed, where we realized the prototype has to be done after the designs are all completed. So the design for industrial design for manufacture, and that design for environment, and the economic analysis became the coupled task. As you can see, from last time, we were behind on the intellectual property search, but we have been able to complete this task without significant delays in our schedule. This is our project design structure matrix, which takes the information from the Gantt chart and places it to show the relationships between the tasks. As you can see here, the coupled task and the parallel tasks are more clearly labeled, and we can see that the tasks not only depend on its immediate predecessors, but predecessors before them. As we can see that the product architecture would require information from not only the concept testing 3, but also from concept testing 1, 2, and all 3 concept generations.
So these are the results of our intellectual property search. So these are 5 patents that are somewhat related to our designs, each from every station. And so this graphic here is a model of the original mousetrap design that was patented in 1962. And so that means that the mousetrap that's used in our first station is free to use. We have a tab-welded turntable, and the tab-welded turntable differs a lot from our own design because it has a lot of voids and protrusions on the main rotating base. The rotating base that our design includes a track, also much smaller, and it doesn't have any of the voids or protrusions, so it should be fine to use. There is also a modular slingshot, and it's different to our design in the sense that our design includes a lever to create tension, as opposed to the modular slingshot being a simple handheld slingshot. The bicycle crank assembly is also another patent that has some interest to us. We are more interested though in 2 specific parts of the bicycle crank assembly, that being the main sprocket for rotation and a chain. And so since we're only using 2 parts from the assembly, they should be readily available. The projectile launcher is also something we're interested in for Station 1. Only the patent that we're taking most of our inspiration from expired in 1972, so we should be fine with that. So these are the results for our concept selection for Station 1. So this, we're starting with a spring launcher, and so the spring launcher launches the ping pong ball behind this wall vertically across into this area where it's going to roll down, activate the Pascal's triangle, and have marbles fall all the way down through the large hole there. And that will be pulling back the final part, which is the mousetrap, and the ball will follow a path and be at rest to be launched by the mousetrap and go into the next station.
This is our failure modes and effective analysis for Station 1, as we use factors such as the severity, the occurrence, and the detection methods to calculate which of the potential failures will have the highest risk priority number and the least. The potential failure with the most risk priority number was the launcher itself, as it needs to be propped up at a 90-degree angle for the launcher to provide enough force to push the ping pong ball up to the top of the station. This can be easily prevented by providing a support block, which will line up already in a preset 90-degree angle, which will have the user just rotate the launcher to rest onto the block. The effective mode potential failure, which would have the least amount of risk priority number, was the lever, as the lever would not have a likely occurrence of failure. But to prevent even a small potential failure, it is possible to add a mass to the side of the lever, which will have a ping pong ball to allow the lever to be more sensitive to the weight and easier to knock down.
So these are our concept results for Station 2. The station begins at a gradual upward incline coming from Station 1, and then a very sharp decline where it remains at rest until the user gets the complete answer. And so it's right before the base is where the ramp will lie, and the hand crank is connected to a path that lies within the base, And once the student reaches the correct answer by rotating the crank, the path will line up directly with the ramp and head on to the next station.
This is the failure modes effective analysis for the station 2, where the place where there's a highest risk priority number would be the wheel itself, as if the wheel becomes jammed, it is impossible to rotate the station to provide a path for the ping pong ball to go through. This can be easily prevented by smoothing out the surface of the wheel itself and the supporting edges of the board, or lubricating the system. The part of the station with the least risk priority number was the sine and cosine graphs, as increased use would lead to the wear of the graph, which might provide small inaccurate readings. This can be easily prevented by supporting the edges of the graphs with plastic, which would reduce the amount of friction caused by the movement of the string, which will which will diminish the wear of the graph itself.
So these are the concept results for our final station, station 3. And so coming from station 2, the ball is at rest and remains under this fan, where the fan activates and it's launched up and in through this path down to this bottom base. And this base it'll be dropped down the center, and it will have the Fibonacci sequence as a guide path, and then a gradual decline where it will exit right out this little nook, and it will remain at rest at the base or at the top of the slingshot. And there'll be 3 slingshots, and the user won't know which ping pong ball, or where the ping pong ball lies, and will have to choose an answer choice to activate the slingshot, and the slingshot will launch it through the exit tube.
So the part of the station which will create the highest risk priority number was the slingshot catapult itself, as if it is not properly aligned, it would either create too much force, which would have the incorrect exit velocity, or it might generate not enough force, which will prevent the ball from reaching the exit of the station. This can be prevented by using projectile motions to properly set the catapult slingshot and the exit of the station in the right places. The part of the station with the least risk priority number was the guiding trail of the spiral, as if this is a very low occurring failure, but it is possible if the trail is propped up at a 90-degree angle that the ball would just end up resting onto the trail without going down. This can be easily prevented by angling the trail, and so that the ball will have an easier flow down with gravity.
We would like to ask for a loan of $1,307,500. We found this value by calculating the number of BRGs we would like to produce per year, which would be 40,000, and then the cost of staff for year 1 versus year 2 and 3. The difference in between the two is that year 1 will be design heavy and engineer heavy, which means the cost of staff will be higher, versus year 2 and 3 will be a lot more production heavy and business heavy. So we decided that it would be lower cost for year 2 and 3 than it would be for year 1, and we decided that we would pay it off over time with an annuity of $191,893.03. And we believe that we will start paying this off at year 2 as soon as the production of the BRGs hits full-fledged potential. And this is the Excel tables that we use to identify each individual value. And so far we've completed our concept generation, our concept testing, and our intellectual properties that we will be using. Going forward, we will need to move on to our prototyping phase and eventually finish the final product.